So guys, in today's video, we are going to see certain tests in which by using those tests, one can distinguish aldehydes from ketones. That means what? For example, assume that you have been given with the two beakers, beaker A and a beaker B. Okay, so both are having a colorless solution. Yes, both the beakers are having a colorless solution. And both the beakers, I would be saying that in any one beaker you are having an aldehyde and in another beaker you are having a ketone. This is my experiment. And the aim of the experiment is you have to say that in which beaker you are having the aldehyde and in which beaker you are having the ketones. I will repeat my question. Since the given task to you is you have been provided with the two beakers having a colorless solution. Mark my words, colorless solution. And you have been said that to identify in which beaker you are having the aldehyde and a ketone. Of course, first fact will be the observation. Since both these solutions are colorless, it will be a quite difficult task to identify through our naked eye. But since it's a chemistry, we know the chemistry deals with the chemicals. So now the question arises that what are the tests we can do so that one can easily say that which beaker contains your aldehyde and which beaker contains your ketones. So do remember such a test to identify your aldehydes. We have been given with the three important tests. Okay, first of all, I will write those names. First is called as Tollen's test. It is also called as a silver mirror test. Silver mirror test. Second one is called as a Fehling's test. F-E-H-L-I-N-G'(S). Fehling's test. And the third one, we can call it as an iodoform test. Iodoform test. So in our today's video, we are going to deal one by one of these tests with a practical demonstration. Okay, this video will be interesting because in each and every test, I have also included a video which would be having a practical demonstrations of these three tests. Okay, shall we carry out? And do remember, all these tests will be giving the positive result only for aldehydes. I am repeating once again, whatever the three tests we have written over here, all the three tests will be giving a positive result only for your aldehydes. Ketones will not give any positive result with respect to these three tests. Okay, shall we begin? So first of all, I would like to go with my Tollen's test. Tollen's test. As I mentioned, it is also called as what? Silver mirror test. Silver mirror test. Why this name? You'll get to know when we see its reaction. So first of all, let us know how we are carrying out this test. Remember guys, first of all, in this Tollen's test, we will be using a Tollen's reagent. Tollen's reagent. So remember, Tollen's reagent is nothing. It is generally your ammonical, very much important. 1 marks question, they can ask you what is Tollen's reagent. So you should remember its composition, ammonical silver nitrate. Ammonical silver nitrate solution is called as what? Tollen's reagent. So here what we are doing basically, the given aldehyde, okay, you are not knowing whether the compound is an aldehyde or ketone, but for our assumption, I am just taking that the given compound is an aldehyde. So whenever you are treating your aldehyde, okay, with this Tollen's reagent, remember, and warming it, you're warming it, okay, we could observe, I'm giving you the observation point, you would be observing a silver mirror. You will be observing a silver mirror, and this silver mirror, why is it so? Because due to the presence of our silver metal which is produced. Due to the presence of silver metal. So what is happening? Let us go with the reaction now, so that it will be better understood. As I mentioned, first I will be taking my aldehyde. Okay, as I mentioned, the Tollen's reagent, the important part in the Tollen's reagent is this part. Ag, NH3 twice and a plus. This part I am writing the ionic reaction. Okay, so this part is very much important, composition of your Tollen's reagent. So as I mentioned, it will be carried out in a basic medium, so 3OH minus. Okay, so it would be giving you, first remember, aldehyde is getting oxidized to carboxylate ion, RCOO minus, plus you will be having your Ag, that is your silver, plus water, plus ammonia. If I am right, let me write it in this single line so that it will be not confusing for you. RCHO plus Ag, NH3 twice, plus in the presence of your basic medium, I am getting as an carboxylic acid, I can say it's a carboxylic ion, plus 2Ag. So here 2Ag NH3 twice plus H2O plus 4NH3. 4NH3. Yes. So what we could observe over here. Now let us see the observation point. So first I have took my aldehyde. I am reacting it with my Tollen's reagent in a basic medium. Ammonical silver nitrate. The name itself is indicating. Ammonia na use ಮಾಡ್ತಾ ಇದೀವಲ್ಲಿ. So it's a base. So ammonium hydroxide we would be using. ಆ hydroxide part na ಇಲ್ಲಿ ಬರ್ತಿದ್ದೀನಿ. Is that clear? So aldehyde na ನೀವು ಯಾವಾಗ Tollen's reagent ಜೊತೆ treat ಮಾಡ್ತೀರಾ, what you are observing, the aldehyde part is getting oxidized to carboxylic acid. Of course I have written as RCO minus, H ಬಂದು attach ಆಗೋ chances ಇರುತ್ತೆ. So it will be giving you what? ಇಲ್ಲಿ ನಮ್ಗೆ ಏನು ಗೊತ್ತಾಗ್ತಾ ಉಂಟು, the aldehyde is getting oxidized. In the meanwhile, you can just observe over here the part. ಇಲ್ಲಿ ನೋಡಿ, the Ag is having the oxidation state as +1. ಆದರೆ ಅದೇನಾಗಿದೆ, ನಿಮಗೆ Ag ಆಗಿ ಕೊಡ್ತಾ ಉಂಟು, there is a metal that is Ag0. ಸೊ ಇಲ್ಲೇನಾಗಿದೆ, ರೆಡ್ಯೂಸ್ಡ್ ಆಗಿದೆ. ಸೊ ಇಲ್ಲಿ ಏನ್ ಫಾರ್ಮ್ ಆಗಿದೆ, ಸಿಲ್ವರ್ ಮೆಟಲ್ ಫಾರ್ಮ್ ಆಗಿದೆ ಅಲ್ವಾ. ದಿಸ್ ಸಿಲ್ವರ್ ಮೆಟಲ್ ಇಸ್ ಆನ್ ದಿ ಅಬ್ಸರ್ವೇಷನ್. ಈಗ ಒಂದು ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ ಅಲ್ಲಿ ನೀವು okay, you have took this aldehyde plus ammonical silver nitrate solution treat ಮಾಡಿ ವಾರ್ಮ್ ಮಾಡಿದಾಗ what we are observing ಅಂದ್ರೆ ಇಲ್ಲಿ ಒಂದು ಸುತ್ತಮುತ್ತ ಫುಲ್ ಪಾರ್ಟ್ ಅಲ್ಲಿ ಸಿಲ್ವರ್ ಮಿರರ್ ಫಾರ್ಮ್ ಆಗಿಬಿಡುತ್ತೆ. ಇದು ನೀವು ಬಗ್ ನೋಡ್ರಿ, you can just see your reflection, okay, like a mirror. So that is the reason it has called as what, silver mirror test. ಯಾಕ ಸಿಲ್ವರ್ ಮಿರರ್ ಬರ್ತಾ ಉಂಟು, because here whatever the silver which was enclosed within the complex, it is becoming free and converting itself to from ion to a metal, and this metal is getting deposited. And we know that silver metal is like a mirror itself ಅಲ್ಲ. ನಾವು ಮಿರರ್ ನ ಕೂಡ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಸಿಲ್ವರ್ ನಮಗೆ ಬೇಕಾಗುತ್ತೆ. ಅದೇ ಸಿಲ್ವರೇ ಇಲ್ಲೂ ಉತ್ಪತ್ತಿ ಆಗ್ತಾ ಉಂಟು. Since the metal is been formed, it gets covered to this test tube, which will be easily reflecting your image. So that is the reason it is called as what, silver mirror test. Getting my point? Very much important. And do remember, it is a test which is only answered by your aldehydes. It is a test which is only answered by your aldehydes. The reaction is very much important. And one important note, what you can observe over here, though it was a test for the aldehyde, but if I see it as a reaction, what you can call it as, ನಾ ಹೇಳಿದೆ ಆಲ್ಕೋಹಾಲ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ, ನೀವು ಆಲ್ಕೋಹಾಲ್ ನ ಆಲ್ಕಲೈನ್ KMnO4 ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದಾಗ ನಿಮ್ಗೆ ಏನ್ ಬಂತು, recall when you treated your alcohol with an alkaline KMnO4, potassium permanganate, a strong oxidizing agent. So you have oxidized alcohol directly to the carboxylic acid ಅಲ್ವಾ. ಅದೇ ನೀವು PCC ನ ಮಾಡಿದ್ರೆ ಫಸ್ಟ್ ನಿಮ್ಗೆ ಆಲ್ಕೋಹಾಲ್ ಇಂದ ಡೈರೆಕ್ಟ್ ನಿಮಗೆ ಆಲ್ಡಿಹೈಡ್ ಬರ್ತಾ ಇತ್ತು. ಇನ್ನೊಂದ್ಸರಿ PCC ನ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಆಲ್ಡಿಹೈಡ್ ಇಂದ ಕಾರ್ಬೋಕ್ಸಿಲಿಕ್ ಆಸಿಡ್. ಸೊ ಅಲ್ಲೂ ಕೂಡ ನಾವು ಆಕ್ಸಿಡೇಷನ್ ಮಾಡಿರೋದು. ಇಲ್ಲೂ ಕೂಡ ಏನಾಗ್ತಾ ಉಂಟು, ಆಲ್ಡಿಹೈಡ್ ಇಂದ ಕಾರ್ಬೋಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಬರ್ತಾ ಇರೋದು. ಸೊ ನಾವ್ ಏನಂತ ಇಲ್ಲಿ ಒಂದು ಹಿಂಟ್ ಗೊತ್ತಾಗ್ತಾ ಉಂಟು ನಮ್ಗೆ. ಸೊ your Tollen's reagent is also an, what you can say, it is oxidizing agent alva. It is oxidizing agent. So Tollen's reagent can be also used as an oxidizing agent. ಇದನ್ನ ಜ್ಞಾಪಕ ಇಟ್ಕೊಂಡ್ರು ಕೂಡ ನಿಮಗೆ ಯಾಕೆ ಈ ಪ್ರಾಡಕ್ಟ್ ಬರ್ತಾ ಉಂಟು, ಯಾಕೆ ನಮಗೆ ಕಾರ್ಬೋಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಬರ್ತಾ ಉಂಟು ಅಂತ ಈಸಿಯಾಗಿ ಡಿಟರ್ಮೈನ್ ಮಾಡಬಹುದು. Since your Tollen's reagent is oxidizing agent, it is oxidizing your aldehyde to carboxylic acid. Is that important? Please note it down. Very much important concept. There are also certain exceptions. I will be dealing it one by one as soon as we have understood this part first. Okay, understand this part. So let us begin with once again. In Madhivatu now, tolerance test, which is also called as a silver mirror test. So in this test, it's basically a test for the identification of our aldehydes. So what you are doing, we are taking our aldehydes and treating it with a Tollen's reagent. What is this Tollen's reagent? It is actually a ammonical silver nitrate solution. We have to only prepare it. Okay, in the lab we can easily prepare it. Ammonical silver nitrate solution. Okay, it's in a basic medium we are doing it. Okay, and when you are warming it, in case if the given compound is having an aldehyde, you can just observe that the silver is formed. ಈ ಅಬ್ಸರ್ವೇಷನ್ ಯಾವ ತರ ಬರುತ್ತೆ, ಒಂದು ಇಡೀ ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ನಿಮ್ಮ ರಿಫ್ಲೆಕ್ಷನ್ ಫುಲ್ ಸಿಲ್ವರ್ ಡೆಪಾಸಿಟ್ ಆಗ್ಬಿಡುತ್ತೆ. Okay, silver deposit. You will be seeing in my practical demonstration in this video itself. But just for a while, you understand the theory part over here. So, a silver yak barta untu, you can just see the reaction. Ag plus ion iradu, Ag not. And metal korta untu. E metal enagta untu deposit agta untu. A metal namge gottalla, metal is having a shining surface. So, since silver which is formed is also having a shining surface, that is the reason it will be acting as a mirror for us. Okay, mirror ಯಾವ ತರ ಮಾಡ್ತಾರೆ, ಜಸ್ಟ್ ಯು ಗೂಗಲ್ ಇಟ್. ಮಿರರ್ ಅಲ್ಲಿ ಕೂಡ ನಾವು ಸಿಲ್ವರ್ ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅದೇ ರೀತಿಲಿ ಇಲ್ಲಿ ಕೂಡ ಸಿಲ್ವರ್ ಫಾರ್ಮ್ ಆಗ್ತಾ ಉಂಟು. ಸೊ ಯು ಕ್ಯಾನ್ ಸಿ ದಿ ರಿಫ್ಲೆಕ್ಷನ್. ಸೊ ದಟ್ ಇಸ್ ದ ರೀಸನ್ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್, silver mirror test. Is that clear? And very much important, this test is an identification for your any type of aldehydes. I repeat, any type of aldehydes. And what is happening over here? Here aldehyde is getting oxidized to carboxylic acid, whereas your Tollen's reagent is getting reduced to silver. ಅದಕ್ಕೆ ಅಲ್ವಾ Tollen's reagent ನಾವು oxidizing agent ಅಂತ ಹೇಳ್ಬೋದು. ಯಾಕೆ oxidizing agents are the one which itself get reduced. You could just see over here. That is the reason, one important note we came to know, that Tollen's reagent can be also act as an oxidizing agent. Is that clear? Okay, now let's have a practical demonstration of our Tollen's reagent.
This video demonstrates how to use Tollen's reagent to test for aldehydes. This video first demonstrates the preparation of Tollen's reagent. Two tests will then be carried out. One shows a positive result, and the other shows a negative result. Preparation of Tollen's reagent. Add 2 ml of 0.3 molar silver nitrate solution into a clean test tube. And then add 1 to 2 drops of 0.3 molar sodium hydroxide solution. Brownish precipitate of silver oxide will be formed. Add a 3 molar aqueous ammonia solution drop by drop with a dropper, until all the silver oxide precipitate is just dissolved. Do not add excess amount of the ammonia solution. The solution obtained is aqueous diamine silver solution, which is also known as Tollen's reagent. Add a small amount of sample to the Tollen's reagent. Shake the mixture gently, and then stand it on the bench for 10 minutes. Observe if there is a silver coating formed on the inner surface of the test tube. If there is no observable change, warm the mixture in a warm water bath for 5 minutes. If the sample is an aldehyde, a positive test result will be obtained. If the sample is not an aldehyde, the test will give a negative result. It is important that Tollen's reagent should be freshly prepared. Prior to disposal, the reagent must be acidified immediately after use. The addition of acid prevents the formation of explosive silver nitride.
So guys, soon after we have seen the tolerance test and also the practical demonstration of a tolerance test. Now let us go with another important test for the identification of our aldehydes, which is called as Fehling's solution or a Fehling's test. Fehling's test. Very much important test. Why is it important? You'll come to know over here. But do remember, whenever we are carrying out this Fehling's test, basically we have to prepare two important solutions. One is called as a Fehling's solution A, Fehling's solution A, and the another is called as a Fehling's solution B, Fehling's solution B. Basically the Fehling solution A is actually your copper sulfate pentahydrate solution. Okay, CuSO4 5H2O. Whereas that of your Fehling solution B, it is an actually alkaline sodium potassium tartarate. Sodium potassium tartarate. ಟಾಟಾರಿಕ್ ಆಸಿಡ್ ಅಲ್ಲಿ COOH ಗ್ರೂಪ್ ಏನಿರುತ್ತಲ್ವಾ ಅದನ್ನ ನಾವು H ನ ರಿಪ್ಲೇಸ್ ಮಾಡಿ ಒಂದ್ ಕಡೆ Na ಗ್ರೂಪ್ ಹಾಕಿರ್ತೀವಿ, ಇನ್ನೊಂದ್ ಕಡೆ ನಮ್ಮ ಪೊಟ್ಯಾಷಿಯಂ ಗ್ರೂಪ್ ಹಾಕಿರ್ತೀವಿ. ಸೊ ಅದೇ ರೀತಿ ಅದು ಯಾವ್ದ್ರಲ್ಲಿ ಮೀಡಿಯಂ ಅಲ್ಲಿ ಪ್ರಿಪೇರ್ ಮಾಡ್ತೀವಿ, ಆಲ್ಕಲೈನ್ ಮೀಡಿಯಂ. ಸೊ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ as ಸೋಡಿಯಂ ಪೊಟ್ಯಾಷಿಯಂ ಟಾಟಾರೇಟ್, TARTARATE. ಓಕೆ, ಸೊ ಈ ಎರಡು ಸೊಲ್ಯೂಷನ್ ನೀವು ಫಸ್ಟ್ ಸಪರೇಟ್ ಆಗಿ ಪ್ರಿಪೇರ್ ಮಾಡ್ಕೋಬೇಕು. ಓಕೆ, ಫ್ರೆಶ್ಲಿ ಪ್ರಿಪೇರ್ಡ್. ವಿ ಕಾಂಟ್ ಯೂಸ್ ದಿ ಒನ್ ವಿಚ್ ಇಸ್ ಬೀನ್ ಆಲ್ರೆಡಿ ಪ್ರಿಪೇರ್ಡ್. ವಿ ಹ್ಯಾವ್ ಟು prepare it, we can say what you can say freshly when it is required. Okay, what we are doing, first you have to prepare whenever you are carrying out a Fehling's test. I repeat once again, Fehling solution A and Fehling solution B you have to prepare. Fehling solution A andre enu, it's a copper sulfate pentahydrate, whereas the Fehling solution B is an alkaline sodium potassium tartarate. Okay, so once you have prepared over here, then what you have to do is you have to mix the two solutions. ಇವೆರಡನ್ನ ಈಗ ಸಪರೇಟ್ ಒಂದು ಬೀಕರ್ ಅಲ್ಲಿ ಪ್ರಿಪೇರ್ ಮಾಡಿರ್ತೀರಲ್ಲ, ದೆನ್ ಟೇಕ್ ಒನ್ ಬೀಕರ್, ಈಕ್ವಲ್ ಪ್ರಪೋರ್ಷನ್. ಇದನ್ನ ಈಗ ಒಂದು 10 ml ತಗೊಂತ ಇದೀನಿ ಅಂದ್ರೆ ಇದನ್ನು 10 ml ತಗೊಂಡು ಎರಡೂನು ಈಗ ಈ ಬೀಕರಿಗೆ ಮಿಕ್ಸ್ ಮಾಡ್ಬಿಡಿ. ಓಕೆ, ಫಸ್ಟ್ ನಾವು ಸಪರೇಟ್ ಆಗಿ ಪ್ರಿಪೇರ್ ಮಾಡ್ಕೋಬೇಕು, ಆಮೇಲೆ ಈಕ್ವಲ್ ಪ್ರಪೋರ್ಷನ್ ಅಲ್ಲಿ ಅವೆರಡೂನು ತಗೊಂಡು ಒಂದು ಬೀಕರಿಗೆ ಹಾಕೋಬಿಡಿ. ಓಕೆ, ದೆನ್ ಯು ಹ್ಯಾವ್ ಪ್ರಿಪೇರ್ಡ್ ಅ Fehling solution. Okay, but remember Fehling solution is having two components. One is Fehling solution A ಒಂದು, Fehling solution B ಒಂದು. ಪ್ರಿಪೇರ್ ಆದ ಕೂಡ ಆ ಈಕ್ವಲ್ ಪ್ರಪೋರ್ಷನ್ ಒಂದು ಬೀಕರಿಗೆ ಹಾಕೋಣ. ಕಾಂಬಿನೇಷನ್ ನಾವೇನಂತೀವಿ, Fehling solution ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ಸೊ ನಾವು ಒನ್ಸ್ ಯು ಹ್ಯಾವ್ ಪ್ರಿಪೇರ್ಡ್ ಯುವರ್ Fehling solution, ಇದಕ್ಕೆ ಏನ್ ಮಾಡಿದ್ವಿ, ಈಗ ನಮ್ಮ ಆಲ್ಡಿಹೈಡ್ ನ ಹಾಕಿ RCHO ನ ಹಾಕಿದಾಗ ಏನಾಗುತ್ತೆ ಅಬ್ಸರ್ವೇಷನ್ ಅಂದ್ರೆ, ಇಫ್ ದಿ ಗಿವನ್ ಕಂಪೌಂಡ್ ಇಸ್ ಆಲ್ಡಿಹೈಡ್, ಐ ರಿಪೀಟ್, if the given compound is aldehyde, I could observe a red brown precipitate. ಏನ್ ಕಾಣುತ್ತೆ ನಮ್ಗೆ, ರೆಡ್ ಬ್ರೌನ್ ಪ್ರೆಸಿಪಿಟೇಟ್. ಟಾಲೆನ್ಸ್ ರಿಯೇಜೆಂಟ್ ಅಲ್ಲಿ ಯಾವ ತರ ನಮ್ಗೆ ಸಿಲ್ವರ್ ಮಿರರ್ ಅಬ್ಸರ್ವೇಷನ್ ಆಗಿ ಬಂತು ಯಾವಾಗ ನಾವು ಆಲ್ಡಿಹೈಡ್ ನ ಯೂಸ್ ಮಾಡಿದ್ವಿ, ಅದೇ ರೀತಿ Fehling solution ನಲ್ಲಿ when you are treating your aldehyde with that of your Fehling solution, you will be observing a red brown precipitate. Of course the question arises, why? Alva, in case we came to know Tollen's reagent, we got the silver mirror because of the production of a silver metal. But what is the reason of this red brown precipitate in Fehling solution? So in order to understand, you have to go through its reaction. As first of all, you are using your aldehyde. Yes, so in the presence of copper sulfate, I am writing my ionic reactions. Important component is Cu2 plus in an alkaline medium I am doing it, so 5OH minus. Of course it is also an oxidizing agent, so first it is going to oxidize your aldehyde to carboxylate ion, RCOO minus, plus this is important, you are getting your Cu2O. So here yav charge unto copper mele nodi, very much important, plus 3 water. So here you will be getting as 2 Cu. I hope so it is balanced. 2, 5, 3 plus 2. Yeah, balanced. Alva. So basically you could just observe here is in Cu is in plus 2 state. Whereas illenagide Cu is in plus 1 state. Alva, nodkolli bekare. Cu plus 1 and O2 minus itself will be giving is what? Cu2O. Cu2O. ಸೊ ಇದೇನಾಗಿದೆ, ಈಗ ಕ್ಯುಪ್ರಿಕ್ ಇಂದ ಕ್ಯುಪ್ರಸ್ ಆಗ್ತಾ ಉಂಟು. Yes or no? Cupric in the cuprous. Of course, now this from here to here it has been oxidized. Alva. Whereas from here to here it has been reduced. So what is the important note we can know? Okay, one more important thing. So as I mentioned, you're getting as what? Red brown precipitate. Yakid barta untu? Because of this part. The cuprous oxide, whatever it has been obtained, is actually a colored component. And this itself is giving you what? Red brown PPT. Red brown PPT. And when it is observed, whenever you are using the main reactant as your aldehyde. ಆಲ್ಡಿಹೈಡ್ ಇದ್ರೆ ಮಾತ್ರ ಈ ಒಂದು ರಿಯಾಕ್ಷನ್ ಆಗಿ ನಿಮ್ಗೆ ನಿಮ್ಮ ಕ್ಯುಪ್ರಸ್ ಆಕ್ಸೈಡ್ ಸಿಗುತ್ತೆ. ಸಿಕ್ಕಿದಾಗ ಏನಾಯ್ತು? ರೆಡ್ ಬ್ರೌನ್ ಪಿಪಿಟಿ ಬರುತ್ತೆ. ಸೊ ದಟ್ ಇಸ್ ಅ ಕನ್ಫರ್ಮೇಟರಿ ಟೆಸ್ಟ್ ವಿಚ್ ಇಂಡಿಕೇಟ್ಸ್ ದಟ್ ದ ಗಿವನ್ ಕಂಪೌಂಡ್ ಇಸ್ ಅನ್ ಆಲ್ಡಿಹೈಡ್. ಅದೇನಾದ್ರೂ ನೀವು ಕೀಟೋನ್ ತಗೊಂಡಿದ್ರೆ ಅಫ್ ಕೋರ್ಸ್ ವಿಲ್ ನಾಟ್ ಬಿ ಗೆಟಿಂಗ್, ಸೊ ವಿಚ್ ವಿಲ್ ಬಿ ಅ ನೆಗೆಟಿವ್ ಟೆಸ್ಟ್. ಅವಾಗ ನಾವು ಈಸಿಯಾಗಿ ಹೇಳ್ಬೋದು ಕೊಟ್ಟಿರೋ ಕಂಪೌಂಡ್ ಆಲ್ಡಿಹೈಡ್ ಅಲ್ಲ. ಬಟ್ ವಾಟ್ ಇಸ್ ದ ಮೇನ್ ರೀಸನ್ ಆಫ್ ಗೆಟಿಂಗ್ ಯುವರ್ ರೆಡ್ ಬ್ರೌನ್ ಪಿಪಿಟಿ? ಬಿಕಾಸ್ ಆಫ್ ದಿ ಫಾರ್ಮೇಶನ್ ಆಫ್ ದಿಸ್ ಕ್ಯುಪ್ರಸ್ ಆಕ್ಸೈಡ್. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ರಿಮೆಂಬರ್, Cu +1 state, +2 in the +1 kadege hogta untu. So it is getting reduced. The culprit which is giving you the red brown precipitate whenever you are treating your aldehyde with that of your Fehling solution is that of your cuprous oxide. Is that clear? Very much important. So let's have a practical demonstration of this Fehling solution now itself.
Hey everyone, quick biochemistry basics here. Let's talk about Fehling's test. Fehling's test is used to distinguish monosaccharides having aldehyde or a keto group. Monosaccharides having aldehyde group gives positive Fehling's test, while the monosaccharides having ketone group gives negative Fehling's test. However, there is an exception over here. Monosaccharides having alpha hydroxy ketone like fructose can also give a positive Fehling's test. Fehling's reagent consists of two solutions which are known as Fehling A and Fehling B. Fehling A is an aqueous solution of copper sulfate which is blue in color, while Fehling B is an aqueous solution of potassium sodium tartrate along with strong alkali such as sodium hydroxide. The final working solution is prepared by mixing equal volume of Fehling A and Fehling B. When monosaccharides are mixed with Fehling solution and heated at 60 degrees Celsius in a water bath, the monosaccharide is oxidized to acid while the Cu+2 ions are reduced to copper oxide. The copper oxides form is reddish or brown in color and can be quantified easily to find the amount of aldose monosaccharide present. This is a very common test used to detect presence of glucose in urine as a positive indication of diabetes.
Aldehydes are also oxidized in the so-called Fehling's test. The oxidizing agent used here is the copper-2 ion in alkaline solution. The reaction produces a brick red precipitate of copper-1 oxide.
So guys, soon after you have seen the Tollen's test for the identification of aldehydes and Fehling's test for the identification of aldehydes. Now let us have certain exceptions in our concept. Exceptions. Okay, very much important in your competitive point of view. Okay, so as I said, these are the tests which are only answered by your aldehydes. I repeat, these are the tests which are only answered by your aldehydes. But that's not the only fact, guys. Remember, along with aldehydes, we are having certain exceptions in our reactants, which also gives a positive result to this Tollen's reagent and a Fehling solution. First important exception is that of your alpha hydroxy ketones. Alpha hydroxy ketones. So the ketone, as I mentioned, ketones will not answer the test, but in a ketone we are having an exception. In ketone, only this alpha hydroxy ketone will be answering the or giving the positive response for your Tollen's test as well as that of your Fehling solution. Yenidu alpha hydroxy ketones andre? So basically CH3, C double bond O, and that of you can say COH H CH3. ಸೊ ಏನ್ ನೋಡ್ಬೋದು ನಾವಿಲ್ಲಿ ನಾ ಅವತ್ತೇ ಹೇಳಿದ್ದೆ ಇದ್ರದ್ದು ಇದೀಗ ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಆಗುತ್ತೆ ಅಲ್ವಾ. ಕಾರ್ಬನ್ ಆಟಮ್ ಇಸ್ ಅಡ್ಜಸೆಂಟ್ ಡಬಲ್ ಬಾಂಡೆಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಲ್ವಾ, ಅಥವಾ ನಿಮ್ಮ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಇನ್ ನೆಕ್ಸ್ಟ್ ಕಾರ್ಬನ್ ಇದು ಆಲ್ಫಾ ಇದು ಆಲ್ಫಾ ಅದೇ ಈ ತರ ಹೋಗ್ತದೆ. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನನಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಉಂಟು. ಸೊ ಈ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಯಾವ್ದು ಹೈಡ್ರಾಕ್ಸೈಡ್ ಯಾವ ಪೊಸಿಷನ್ ಉಂಟು ಆಲ್ಫಾ ಪೊಸಿಷನ್ ಅಲ್ಲಿ. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್ ಆಲ್ಫಾ ಹೈಡ್ರಾಕ್ಸಿ ಕೀಟೋನ್. ಈ ತರ ನೀವು ಬೇಕಾದ್ರೆ ಚೈನ್ ನ ಎಳ್ಕೊಂಡು ಹೋಗ್ಬೋದು, ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಆದ್ರೆ ಇಂಪಾರ್ಟೆಂಟ್ ಏನು, ಇಟ್ ಶುಡ್ ಹ್ಯಾವ್ ಅನ್ hydroxy group in an alpha position and moreover it should be a ketone. So ಈ ತರ ketones ಕೂಡ ನಮಗೆ ಪಾಸಿಟಿವ್ ಟೆಸ್ಟ್ ಕೊಡುತ್ತೆ with respect to your Tollen's reagent and that of your Fehling solution. ಯಾಕೆ ಅಂತ ಹೇಳ್ತೀನಿ. ಫಸ್ಟ್ ನಾವು ಎಕ್ಸೆಪ್ಷನ್ಸ್ ನೋಡ್ಕೊಬಿಡೋಣ. ಅದೇ ರೀತಿ your formic acid, carboxylic acid is one and only acid which is also giving the positive test for your Tollen's and the Fehling's test is your formic acid, that is HC double bond OOH. So formic acid is also giving a positive test for your Tollen's reagent and your Fehling solution. Third important point is your hemiacetal. Yeah, the same hemiacetal when you're treating your carbonyl compounds with 1 mole of alcohol. ಏನ್ ಬರ್ದಿದ್ವಲ್ಲ ಅದೇ hemiacetal also gives you the positive test for our Tollen's reagent and the Fehling solution. And the most important point is your terminal alkynes. Terminal alkynes in the last part alli. Okay, this is an important note you should remember. An additional information antane helbodu. ಈಗ for example RCH, okay, 1 2 3. So RC triple bond CH. ಈ ತರ ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಆಲ್ಕೈನ್ಸ್ ಇರುತ್ತಲ್ಲ, ಐ ಆಮ್ ನಾಟ್ ಟಾಕಿಂಗ್ ಓನ್ಲಿ ಆಫ್ ಆಲ್ಕೈನ್ಸ್, ಐ ಆಮ್ ವೆರಿ ಮಚ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಟರ್ಮಿನಲ್ ಆಲ್ಕೈನ್ಸ್. ಸೊ ಟರ್ಮಿನಲ್ ಆಲ್ಕೈನ್ಸ್ ಮೀನ್ಸ್ ಆ ಒಂದು ಟ್ರಿಬಲ್ ಬಾಂಡ್ ನಿಮ್ಮ ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಓಕೆ, ಅಥವಾ ಫಸ್ಟ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಟ್ರೀಮ್ ಎಂಡ್ಸ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಆ ತರ ಆಲ್ಕೈನ್ಸ್ ಏನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ ದೇ ಆಲ್ಸೋ ಗಿವ್ ಅ ಪಾಸಿಟಿವ್ ಟೆಸ್ಟ್ ಫಾರ್ ಅವರ್ Tollen's reagent and the Fehling's solution. Now let us go with one by one why they are giving the positive test. So guys, now when I am considering, for example, my alpha hydroxy ketone, let me take it in this way: CH3, C double bond O, CH2OH. Yes, this is an alpha hydroxy ketone. Why? Because this is my alpha carbon atom, and to that alpha carbon atom I am having my hydroxy group, and also I am also having a ketonic group. So alpha hydroxy ketone. As I have mentioned, this is an exception where you're getting a positive response with respect to the Tollen's test and also your Fehling's test, even though it is being a ketone. The only answer to this is because if I am considering that this is my jar in which I am kept this alpha hydroxy ketone. Of course, when I am seeing acid, it will be remaining as a ketone. But in this jar, it is tautomerizing. The same tautomerization which I have dealt in my previous video. ಏನಾಗುತ್ತೆ, ಈ ಒಂದು ಸ್ಟ್ರಕ್ಚರ್ ಅಲ್ಲೇ ಒಳಗೆ ಒಂದು ಅರೇಂಜ್ಮೆಂಟ್ ನಡೀತಾ ಇರುತ್ತೆ. ಯಾವ ತರ ಅರೇಂಜ್ಮೆಂಟ್ ಸರ್? ಫಸ್ಟ್ ಆಫ್ ಆಲ್, ಲೆಟ್ us look after it. As I mentioned, this alpha hydroxy ketone, it first tautomerizes to first of all enolic convert ಆಗುತ್ತೆ. ಯಾವ ತರ? CH3C ಇದೇನಾಗುತ್ತೆ, ಇದು ತನ್ನ ಕಡೆಗೆ ಎಳ್ಕೊಬಿಡುತ್ತೆ, O ಮೈನಸ್ ಆಯ್ತು, ಇಲ್ಲಿಂದ ಒಂದು ಹೈಡ್ರೋಜನ್ ನ ತನ್ನ ಕಡೆಗೆ ಎಳ್ಕೊಳುತ್ತೆ. ಅವಾಗ ಆ ಹೈಡ್ರೋಜನ್ ಇರೋ ಬಾಂಡು ಇಲ್ಲಿಗೆ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಅವಾಗ ಏನ್ ಬರುತ್ತೆ ನಿಮ್ಗೆ, C ಇಲ್ಲಿ OH ಡಬಲ್ ಬಾಂಡ್ CH ಅಂಡ್ OH. ಸೊ ಫಸ್ಟ್ ಇಟ್ ಇಸ್ ಆಲ್ಫಾ ಹೈಡ್ರಾಕ್ಸಿ ಕೀಟೋನ್ ಇಂದ ಫಸ್ಟ್ ಏನಾಗ್ತಾ ಉಂಟು, ಇನಾಲ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಉಂಟು. ಫಸ್ಟ್ ಟಾಟೋಮೆರಿಸಮ್ ಇಸ್ ಇನಾಲ್. ಇಟ್ ಡಸಂಟ್ ಸ್ಟಾಪ್ಸ್ ಓವರ್ ಹಿಯರ್. ಒನ್ಸ್ ಅಗೇನ್ ದಿಸ್ ಇನಾಲ್, ದಿಸ್ ಇಸ್ ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್. ಈಗ ಯಾವ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತದೋ ಅದನ್ನು ಗಮನ ಇಟ್ಟು ನೋಡಿ. ಓಕೆ, CH3COH. ಓಕೆ, ಈಗ ಇಲ್ಲಿ ಒಂದು H, ದೆನ್ ಸಿಂಗಲ್ ಬಾಂಡ್ C ಡಬಲ್ ಬಾಂಡ್ O ಅಂಡ್ H. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು, ಈ H ಏನಿತ್ತಲ್ವಾ ಇದೀಗ ಈ ಕಡೆಗೆ ಬರ್ತಾ ಉಂಟು. ಸೊ ಅವಾಗ ಏನಾಯ್ತು, ದಟ್ ಇಸ್ ಗಿವಿಂಗ್ ಯು ದಿ double bond character. But what is the main thing we can observe over here? When I am seeing the final tautomerism structure, I could see my aldehyde group. Yes or no? I could see my aldehyde group. Yes. Now you will come to know that why does your alpha hydroxy ketones are giving a positive response for your Tollen's test as well as a Fehling's test, because the alpha hydroxy ketones tautomerizes to that of your aldehyde itself. And since aldehyde gives a positive test for our Tollen's reagent and that of your Fehling's reagent, that is the reason alpha hydroxy ketone also gives. Is that clear? Very much important. ಇದನ್ನ ಎಕ್ಸ್ಪ್ಲೇನೇಷನ್ ನಿಮ್ಗೆ ಯಾರು ಕೇಳೋದಿಲ್ಲ, ಬಟ್ ಗೊತ್ತಿರಬೇಕು ಯಾಕೆ ಆಗ್ತಾ ಉಂಟು ಅಂತ. ಓಕೆ, ಫಾರ್ ದಟ್ ರೀಸನ್ ಐ ಆಮ್ ಜಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲೇನಿಂಗ್. ಆಲ್ಫಾ ಹೈಡ್ರಾಕ್ಸಿ ಕೀಟೋನ್ ಇಸ್ tautomerizing to an aldehyde, and that is the reason it is giving a positive test for our Tollen's reagent and the Fehling's solution. Now coming with respect to my formic acid. So of course when I am talking about my formic acid, remember it is in the resonance ಅಂತಾನೆ ಹೇಳ್ಬೋದು. ಯಾವ ತರ ರೆಸೋನೆನ್ಸ್ ಸರ್, ಈ ಒಂದು H ಮೈನಸ್ ನ ಕೊಟ್ಟಿ it will be in this way, C double bond O minus and also HC single bond here, O double bond here O. But what you can observe over here, after the giving of this proton, ಇದು ಕೂಡ ಒಂದು resonance structure ಅಲ್ಲಿ ನಿಮ್ಮ formic acid exist ಆಗ್ತಾ ಉಂಟು. So here you could just see, yeah, which is this group, please mark my words, which is this group, once again an aldehyde, once again an aldehyde. So formic acid is having a resembling characters of your aldehyde. That is the reason once again your formic acid is giving you the positive test for your Tollen's reagent as well as that of your Fehling's reagent. Clear? Alpha hydroxy ketone ಯಾಕೆ ಕೊಡ್ತು, aldehyde group ಬರ್ತಾ ಉಂಟು. Formic acid ಯಾಕೆ ಕೊಡ್ತಾ ಉಂಟು, aldehyde group ಬರ್ತಾ ಉಂಟು. Hemiacetal ಗೆ ಹೋಗೋಣ. So how will you write hemiacetal? R COH OR and a H. ಸರ್ ನಮಗ್ ಬರೆಯಕ್ ಗೊತ್ತಿಲ್ಲ, ಸೊ ಏನ್ ಹೇಳ್ಬೇಕು, ಫಸ್ಟ್ ನೀವು ಕೀಟೋ ಇದು ಕಾರ್ಬನಿಕ್ ಕಾಂಪೌಂಡ್ ನ 1 mole ಆಫ್ ಆಲ್ಕೋಹಾಲ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿ. ಅವಾಗ ಏನಾಗುತ್ತೆ, RO ಮೈನಸ್ ವಿಲ್ ಬಿ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್, H ಪ್ಲಸ್ ವಿಲ್ ಬಿ ಅನ್ ಎಲೆಕ್ಟ್ರೋಫೈಲ್. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, COH ಇಲ್ಲಿಗ OR ಅಂಡ್ ಆಸ್ ಇಟ್ ಇಸ್ ಅದನ್ನೇ ಬರ್ತಿದೆ. ಇಲ್ಲಿ ನನ್ನ R ಇತ್ತು, ಇಲ್ಲಿ ನನ್ನ H ಇತ್ತು. ಕೀಟೋನ್ ಆಗಿದೆ, ಇಲ್ಲಿ ಯಾರು ಬರೋದು. ಇಸ್ ದಾಟ್ ಕ್ಲಿಯರ್? ಓಕೆ. ಸೊ ನಾವು ವಾಟ್ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಓವರ್ ಹಿಯರ್, ಫಸ್ಟ್ ಇದು ನಾ ಏನ್ ಮಾಡ್ತೀನಿ, Tollen's reagent ಟ್ರೀಟ್ ಮಾಡ್ತೀನಿ. ನಂಗೇನ್ ಗೊತ್ತು, Tollen's reagent ಇಸ್ ವಾಟ್, ಇಟ್ಸ್ ಅನ್ ಅಮಾನಿಕಲ್, ಮೀನ್ಸ್ ಬೇಸ್ ಇರುತ್ತೆ. ಸೊ OH ಮೈನಸ್ ಉಂಟು. ಈ OH ಮೈನಸ್ ಏನು, ಇಟ್ ಇಸ್ ಆಕ್ಟಿಂಗ್ ಆಸ್ ಅ ಬೇಸ್. ಸೊ ಬೇಸಿನ ಮೇನ್ ಪ್ರಾಪರ್ಟಿ ಏನು, ಇಟ್ ಕ್ಯಾನ್ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಅ ಪ್ರೋಟಾನ್. ಸೊ ಇದೇನ್ ಮಾಡುತ್ತೆ, ಇಟ್ ವಿಲ್ ನಾಟ್ ರಿಮೇನ್ ಕ್ವೈಟ್, ಇಟ್ ವಿಲ್ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ದಿಸ್ H ಟುವರ್ಡ್ಸ್ ಇಟ್ ಸೆಲ್ಫ್. ಸೊ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದಾಗ ಏನಾಯ್ತು, ಈಗ O ಮೇಲೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬಂದ್ರೆ ಏನಾಯ್ತು, ಈ ಬಾಂಡ್ ಹೆಂಗು ಒಂದೇ ಬಾಂಡ್ ಉಂಟು, ತುಂಬಾನೇ ಕಷ್ಟ. ಸೊ ಅದೇನ್ ಮಾಡುತ್ತೆ, ಈಗ ಇದನ್ನ ಹೊರಕಳಿಸುತ್ತೆ. ಇದನ್ನ ಹೊರಕಳಿಸಿದಾಗ H ಇಸ್ ಗೋಯಿಂಗ್ ಆಸ್ ವಾಟ್, ಆಸ್ ಅ H ಪ್ಲಸ್ ಇಟ್ ವಿಲ್ ಬಿ ಗೋಯಿಂಗ್ ಔಟ್. ಸೊ ಆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಇಲ್ಲಿ ಹಾಕ್ಸ್ಕೊಳುತ್ತೆ. ಸೊ ಅವಾಗ ಏನಾಯ್ತು, H2O ಹೊರಗೋಯ್ತು, OR ಮೈನಸ್ ಹೊರಗೋಯ್ತು, ಉಳಿದಿದೇನು R C double bond O and a H. So from the hemiacetal, once again we are getting our aldehydes. Yes or no? So in all the three cases, what is the main thing we are observing? Though the main reactants were different, but they are within themselves, they are converting to aldehydic structures. And since aldehydes gives the positive test for your Tollen's reagent as well as that of your Fehling solution, this is giving the positive test for your Tollen's reagent and the Fehling's reagent. Is that clear? Okay, very much important. Coming to my alkynes. ಆಲ್ಕೈನ್ಸ್ ಅಲ್ಲಿ ಹೇಳಿದೆ ಏನಂತ, ಟರ್ಮಿನಲ್ ಆಲ್ಕೈನ್ಸ್ ಮಾತ್ರ ಕೊಡಕ್ಕೆ ಸಾಧ್ಯ. ಯಾಕೆ ಸರ್? ಬಿಕಾಸ್ ರಿಮೆಂಬರ್ ಗೈಸ್, RC ಟ್ರಿಪಲ್ ಬಾಂಡ್ CH ನನ್ನ ಜೊತೆ ನನ್ನ ಆಲ್ಕೈನ್ ಅಲ್ಲಿ ಹೆಚ್ಚಿದ್ರೆ ಮಾತ್ರ, ಆಲ್ಕೈನ್ಸ್ ಅಲ್ಲಿ ಹೆಚ್ಚಿದ್ರೆ ಮಾತ್ರ ಐ ಕ್ಯಾನ್ ಕ್ಯಾರಿ ಔಟ್ ದಿಸ್ ರಿಯಾಕ್ಷನ್ ಟುವರ್ಡ್ಸ್ ಮೈ ಟಾಲೆನ್ಸ್ ರಿಯೇಜೆಂಟ್. ಈಗ ನೀವೆಲ್ಲಾದ್ರೂ ಬೇರೆ ಆಲ್ಕೈನ್ಸ್ ತಗೊಂಡ್ರಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ CH3 C ಟ್ರಿಪಲ್ ಬಾಂಡ್ C ಸಿಂಗಲ್ ಬಾಂಡ್ CH2, ಇಲ್ಲೆಲ್ಲ ಇದು ನನ್ನ ಆಲ್ಕೈನ್ಸ್ ಅಲ್ವಾ, ಇಲ್ಲೆಲ್ಲೂ ನನಗೆ ಹೆಚ್ಚಿಲ್ಲ. ಹೆಚ್ಚು ಯಾವಾಗ ಬರಕ್ ಸಾಧ್ಯ? ಇಲ್ಲ ಅದು ಫಸ್ಟ್ ಅಲ್ಲಿ ಇರಬೇಕು, ಇಲ್ಲ ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಇರಬೇಕು, ಇಲ್ಲ ಏನಾಗಿರ್ಬೇಕು, ಈಥೈನ್ ಆಗಿ ಇರ್ಬೇಕಷ್ಟೇ. ಅವಾಗ ಮಾತ್ರ ಏನಾಗಿರುತ್ತೆ, ಹೆಚ್ಚಿರುತ್ತೆ. ಈ ಹೆಚ್ಚಿದ್ರೆ ಮಾತ್ರ ನನಗೆ ನನ್ನ ಟಾಲೆನ್ಸ್ ರಿಯೇಜೆಂಟ್ ಪಾಸಿಟಿವ್ ರೆಸ್ಪಾನ್ಸ್ ಕೊಡುತ್ತೆ. ಸೊ ವೆನ್ ಐ ಟ್ರೀಟ್ ದಿಸ್ ಒನ್ ವಿತ್ ಮೈ silver ammonical nitrate, that's my Tollen's reagent, AgNH3 twice plus in the presence of a base. ಸೊ ಏನಾಗುತ್ತೆ, ಈ H ನ ರಿಪ್ಲೇಸ್ ಮಾಡಿ ಅಲ್ಲಿಗ ಬಂದು ನನ್ನ ಸಿಲ್ವರ್ ಕೊಡುತ್ತೆ. ಅಂಡ್ ವೆನ್ ದಿಸ್ ರಿಯಾಕ್ಷನ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್, ಇಟ್ ವುಡ್ ಬಿ ಗಿವಿಂಗ್ ಯು ಅ white precipitate. It would be giving you a white precipitate. So this is an observation which indicates that whatever the given compound is there, it is consisting of a terminal alkynes. Terminal alkynes. White precipitate. I'm not saying it's a silver mirror. Okay. ಅದು ಯಾವಾಗ ಬರ್ತಾ ಉಂಟು, ಟಾಲೆನ್ಸ್ ರಿಯೇಜೆಂಟ್ ಜೊತೆ ಬರ್ತಾ ಉಂಟಲ್ಲ, ಸೊ ಇಟ್ ಇಸ್ ಐ ಆಮ್ ಸೇಯಿಂಗ್ ದಟ್ ಇಟ್ ಇಸ್ ಗಿವಿಂಗ್ ಅ ಪಾಸಿಟಿವ್ ರೆಸ್ಪಾನ್ಸ್. ಆದ್ರೆ ಇವೆಲ್ಲದರಲ್ಲೂ ನಮ್ಗೆ ಏನ್ ಬರ್ತಾ ಉಂಟು, ಸಿಲ್ವರ್ ಮಿರರೇ ಬರುತ್ತೆ. ಆದ್ರೆ ಆಲ್ಕೈನ್ಸ್, ಟರ್ಮಿನಲ್ ಆಲ್ಕೈನ್ಸ್ ಅಲ್ಲಿ ನಮ್ಗೆ ವೈಟ್ ಪ್ರೆಸಿಪಿಟೇಟ್ ಬರ್ತಾ ಉಂಟು. ಓಕೆ, ಇಟ್ಸ್ ನಾಟ್ ನೀಡೆಡ್, ಬಟ್ ಫಾರ್ ಅ ಬೆಟರ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಈಗ ನಿಮ್ಮ ಮನ್ಸ್ಲಿ ಕೂತ್ ಬಿಡುತ್ತೆ ಅಲ್ವಾ, ಆ ರೀಸನ್ ಇಂದಾನೆ ನಾ ಇದನ್ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿರೋದು. ಸೊ ರಿಮೆಂಬರ್, ದಿಸ್ ಆರ್ ದಿ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ಸ್ ಫಾರ್ ಯೋರ್ ಎಕ್ಸೆಪ್ಷನ್ಸ್. ಆಲ್ಫಾ ಹೈಡ್ರಾಕ್ಸಿ ಕೀಟೋನ್ ಕೂಡ ಟಾಲೆನ್ಸ್ ರಿಯೇಜೆಂಟ್ ಮತ್ತೆ ಫೆಲಿಂಗ್ಸ್ ರಿಯೇಜೆಂಟ್ ಗೆ ಪಾಸಿಟಿವ್ ರೆಸ್ಪಾನ್ಸ್ ಕೊಡುತ್ತೆ, ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಗೆಟಿಂಗ್ ಟಾಟಮರೈಸಿಂಗ್ ಟು ಯೋರ್ ಆಲ್ಡಿಹೈಡ್. ಫಾರ್ಮಿಕ್ ಆಸಿಡ್ ಅಲ್ಲಿ ಕೂಡ ನಮ್ಮ ಆಲ್ಡಿಹೈಡಿಕ್ ಪ್ರಾಪರ್ಟೀಸ್ ಇರುತ್ತೆ, so it will be giving a positive response. Hemiacetal in the presence of a base, once again it is giving you the aldehyde itself, and that aldehyde of course when treated with the Tollen's reagent it will be giving you the silver mirror. Terminal alkynes ಅಲ್ಲಿ ಹೆಚ್ಚಿದ್ರೆ ಅದು ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ, Ag ಬಂದ್ ಕೊಡುತ್ತೆ, ನಿಮ್ಗೆ white precipitate ಕೊಡುತ್ತೆ. So these are certain exceptions with respect to your Tollen's reagent and that of your Fehling's solution. Okay, now one question arises. Okay sir, Tollen's reagent ಮಾಡ್ತಾರ ಕೆಲಸನು ಒಂದೇ, ಫೆಲಿಂಗ್ಸ್ ರಿಯೇಜೆಂಟ್ ಮಾಡ್ತಾರ ಕೆಲಸನು ಒಂದೇ. ಹಾಗಾದ್ರೆ ಯಾಕೆ ನಾವು ಫೆಲಿಂಗ್ಸ್ ರಿಯೇಜೆಂಟ್ ನ ಎಕ್ಸ್ಕ್ಲೂಡ್ ಮಾಡಬಾರ್ದು, ಯಾಕೆ ನಮ್ಗೆ ಎರಡೂ ಬೇಕು ಅಲ್ವಾ? ಸೊ ಆ ಒಂದು ಕ್ವಶನ್ ಗೆ ಆನ್ಸರ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ನಾನು ನನ್ನ ಬೆನ್ಸಾಲ್ಡಿಹೈಡ್ ನ ಯೂಸ್ ಮಾಡಬೇಕು. ಯಾಕೆ ಸರ್ ಬೆನ್ಸಾಲ್ಡಿಹೈಡ್ ಅಂದ್ರೆ, ರಿಮೆಂಬರ್ ವೆನ್ ದಿಸ್ ಬೆನ್ಸಾಲ್ಡಿಹೈಡ್ ಇಸ್ ಟ್ರೀಟೆಡ್ ವಿತ್ ಟಾಲೆನ್ಸ್ ರಿಯೇಜೆಂಟ್, ಆಫ್ ಕೋರ್ಸ್ ಇಟ್ ವಿಲ್ ಗೆಟ್ ಆಕ್ಸಿಡೈಸ್ ಟು ಯೋರ್ benzoic acid, problem illa. But when the same benzaldehyde is treated with a Fehling's reagent, it will not give you any reaction. It will not give you any reaction. Question arises, why? So comparatively, Tollen's reagent are better oxidizing agent than that of your Fehling's reagent. ಏನ್ ಹೇಳ್ತಿದ್ದಾರೆ, ಟಾಲೆನ್ಸ್ ರಿಯೇಜೆಂಟ್ ಹತ್ರ ಇರೋ ಕೆಪಾಸಿಟಿ ಏನುಂಟಲ್ಲ, ಆಕ್ಸಿಡೈಸಿಂಗ್ ಪ್ರಾಪರ್ಟೀಸ್ ಕೆಪಾಸಿಟಿ, ದ ಕೆಪಾಸಿಟಿ ಆಫ್ ದಿ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಪವರ್ ಆಫ್ ದಿ ಟಾಲೆನ್ಸ್ ರಿಯೇಜೆಂಟ್ ಇಸ್ ಮೋರ್ ದ್ಯಾನ್ ದಟ್ ಆಫ್ ಯೋರ್ ಫೆಲಿಂಗ್ಸ್ ರಿಯೇಜೆಂಟ್, and that is the reason these two reagents has this vital role. Now if you have been given with, for example, CH3CHO and that of your benzaldehyde, ಎರಡು aldehyde, you can just distinguish it. Of course I can. ಇವೆರಡು ಟೆಸ್ಟ್ ಈಗ ನಾನು ಯಾವ್ದಲ್ಲಿ ಟಾಲೆನ್ಸ್ ಅಲ್ಲಿ ಮಾಡಿದ್ರೆ ಸಿಲ್ವರ್ ಮಿರರ್ ಬಂದೇ ಬರುತ್ತೆ. ಅದೇ ಎಲ್ಲಾದ್ರೂ ನಾನು ಫೆಲಿಂಗ್ಸ್ ರಿಯೇಜೆಂಟ್ ಅಲ್ಲಿ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಇದರಲ್ಲಿ ನಂಗೆ ರೆಡ್ಡಿಶ್ ಬ್ರೌನ್ ಪ್ರೆಸಿಪಿಟೇಟ್ ಬರುತ್ತೆ, ಇದರಲ್ಲಿ ನಂಗೆ ಯಾವ ತರದ್ದು ರಿಯಾಕ್ಷನ್ ಆಗಲ್ಲ. So this is one more important note you have to remember. What is that? Your aromatic aldehydes. I repeat, the aromatic aldehydes which are not having any alpha hydrogens, okay, they will not give a positive test to your Fehling's reagent. Very much important concept. Okay, very much important guys in both point of your exam and also for your competitive exams. Okay, competitive exams ಅಲ್ಲಿ ಬೇಸಿಕ್ exceptions ಅಲ್ಲಿ questions ಮಾಡೋದು ತುಂಬಾನೇ ಇರುತ್ತೆ. So you have to remember the exceptions and also this important fact that what is that Tollen's reagent are the far better oxidizing agent when compared to that of your Fehling's reagent. ಅದಕ್ಕೆ ನಾವು ಇಲ್ಲಿ ನೋಡಿದ್ದೇವೆ, Tollen's reagent has the capacity to oxidize your aromatic aldehydes, but Fehling's reagent will not have the capacity to oxidize your aromatic aldehydes. Is that clear? Very much important. So the next part, the last part of this video we are going to see, which is called as haloform reaction. Yeah, the same reaction which we have read in the oxidation of your methyl ketones. ಅದೇ reaction ಕೂಡ ನಾವು ಇಲ್ಲಿ ಯಾಕೆ ಯೂಸ್ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ, because this is also a reaction in which you can identify your methyl ketones. ಈ ಐಡೆಂಟಿಫಿಕೇಶನ್ ಟೆಸ್ಟ್ ಗೆ ಯೂಸ್ ಮಾಡಬಹುದು. ಆ ರೀಸನ್ ಇಂದನೇ ಇಲ್ಲಿ ನಾವು ನೋಡ್ತಿದೀವಿ. And basically in haloform, the most important I would like to choose is the iodoform reaction. Iodoform reaction. Yake sir? Because guys, when you're treating your methyl ketones with this, what you can say, sodium hypoiodide, whatever the iodoform will be formed, alva, it will be obtained as an LOPPT. Since the obtained precipitate is a colored one, it can be used as a test to distinguish your methyl ketones from other ketones. Is that clear? So now we will look after those reactions in this video itself, along with a practical demonstration. So guys, in a haloform reaction, we have studied that it was an oxidation reaction. Of course, a Tollen's reaction is also an oxidation reaction. Your Fehling's reaction is also oxidation reaction. But here also, your haloform is also an oxidation reaction. And we came to know from the previous video that whenever you're treating your methyl ketones, very much important, the compound, if it has to give a positive response with respect to the haloform reaction, it should have a methyl ketone. ಈ CO ಜೊತೆ CH3 ಗ್ರೂಪ್ ಅಟ್ಯಾಚ್ ಇದ್ರೆ ಮಾತ್ರ ನಮಗೆ ನಮ್ಮ ಪಾಸಿಟಿವ್ ರಿಸಲ್ಟ್ ಬರುತ್ತೆ ಅಲ್ವಾ. So when you're treating this one with your sodium hypohalides, for example, if I take NaOX generally, so of course I said you will be getting a sodium salt of a carboxylic acid plus important haloforms alva. So this was a general reaction. In this part or in this video, we are mainly concentrating about my iodoform reaction, because when it is forming as a CHI3, whatever the compound it will be forming, it will be having an LO precipitate. And when it will be performed, or when you will be getting that one, whenever we are having a methyl ketones. Is that clear? So one important point we came to know that if you have to obtain a positive result for the iodoform reactions, first important point, you should have the group in your reactant one in this way. Methyl ketones, it will give a positive test for haloform. Positive test for haloform. But now I would like to mainly deal with an exception over here. What is that exception? Even though these methyl ketones are not there, but if you are having a compound or a reactant like this, CH3, CHOH, and any other compound it would be, these compounds are also giving a positive test for haloform. Of course, this is a part, or you can take a type of a secondary alcohol. Secondary alcohol. Why I'm saying as a type, very much important. Every secondary alcohol, cannot say that each and every secondary alcohol will not give a positive test. Secondary alcohol of the type CH3CHOH, that is the OH ಯಾವ ಕಾರ್ಬನಿಗೆ ಅಟ್ಯಾಚ್ ಆಗಿದೆಯೋ ಆ ಕಾರ್ಬನಿಗೆ ಒಂದು ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಇರಲೇಬೇಕು ಅಂತ ಒಂದು ಕಂಪೌಂಡ್ ಮಾತ್ರ will be giving a positive test for haloform. What I am saying, all secondary alcohols will not give the haloform reaction. Why I am saying this? Because the secondary alcohol in which the hydroxy group which will be attached to the secondary carbon, of course, but that secondary carbon should also be attached to a methyl group. Only such compounds will give a positive test for haloform. Of course, now one a big question mark arises. Why is it so? Okay, let us take an example. Let me take as a CH3CHOH CH2CH3. What I have done, I have just added over here CH2CH3. Of course, I know that I am doing a haloform and it is an oxidation reaction. So in case if I am proceeding this reaction with my iodoform, idenagutte oxidize agutte. What you will get, my question to you, what you will get on oxidation of secondary alcohols. What you are getting on oxidation of secondary alcohols. Remember, you will be getting ketone. You will be getting ketone. So again ಆಗುತ್ತೆ, ಫಸ್ಟ್ ನಿಮ್ಗೆ ಕೀಟೋನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಯ್ತು. ಇದು ಯಾವ ತರದ ಕೀಟೋನ್ ಆಯ್ತು ಈಗ? ಮಿಥೈಲ್ ಕೀಟೋನ್ ಆಯ್ತಾ? Yes or no? Of course we know that methyl ketones undergo what? Haloform reaction. So on treating now this one with NaOI, what you would be getting? Of course now you would be getting your part NaOI, sodium hypoiodide. So now idenagutte, you will be getting as CH3 COO minus Na plus CH3 CH2I3 iodoform. Yes or no? Iodoform. So this is the reason I am saying that whatever the other compound you are taking, it should have a methyl group attached to that secondary carbon, which is further attached to our hydroxy group. Yes or no? So that is the reason I said you that all secondary alcohols will not give you, because if I consider a reaction is in this way, CH3, okay, CH3, CH, C, OH, 1, 2, 3, 4, and over here as a CH2, CH3. Can this undergo this haloform reaction? Of course not. Why? Because when it oxidizes, it would be giving as a CH3, CH2, C double bond O, CH2, CH3. Of course, it's giving a ketone, but that ketone is not having on either sides the methyl group. So if it is not a methyl ketone, of course, it will not undergo your haloform reactions, and more particularly your iodoform reaction. So now if I give you a question, let us solve certain questions. My first question to you, whether this compound can undergo haloform reaction. Yes, of course, yes. Enu bardila andre artha enu, it is a methyl group, so it is having CH3COH. So this compound will undergo the haloform reaction to form a corresponding carboxylate ion and a haloform. What about this compound? If I say like this, yeah, whether this compound will undergo haloform reaction? Of course not. Why? Here also it is having CH2, here also it is having CH2. Either side alli kuda namge yav taradu methyl group illa. Methyl andre artha enu CH3 idre matra methyl, CH2 irbardu, CH3 ne irbeku. Yadru ond kade yadru CH3 ididro idu haloform agadu, adre eld kadenu idukke CH3 group is not there. So that is the reason it will not undergo haloform reaction, whereas the first one will undergo the haloform reaction. So first what you will be getting? CH3 CH2 COO minus Na and a CH3I3, sorry, CHI3. Here what you will be getting, here this reaction will not proceed itself, so it will not give you the haloform reaction. Are you getting my point? So that is the reason I have included my haloform reaction in this video itself. Remember, Tollen's test, Fehling's test, haloform test are all the three tests which are identification for your aldehydes and ketones. The first two, that is your, which you can say as an Tollen's test and the Fehling's test, they are the identification for aldehydes, whereas that of your haloform test is the identification of your methyl ketones. Remember, methyl ketones, the compound which will be having like this COCH3, E compound matra ನಿಮ್ಮ haloform reaction ಆಗೋದು. ಆ haloform ಅಲ್ಲಿ ನಾನು more particular iodoform ತಗೊಂತೀನಿ. ಯಾಕೆ? Chloroform ಆಗಿರಬಹುದು, bromoform ಆಗಿರಬಹುದು, they are not having a colored precipitate, whereas this iodoform is having a colored precipitate. So whenever we treat an methyl ketones with the sodium hypoiodide, we will be getting an iodoform which will be having an yellow PPT, which can be used as a test for the identification of methyl ketones. So when we are seeing its exception, of course, a type of a secondary alcohol, that is of the form CH3CHOH, like this compounds also undergo the haloform reaction, because when they oxidize, they will be giving you all the respective methyl ketones, and once you get the methyl ketones, of course, they will undergo the iodoform or the haloform reaction. Is that clear? So in today's video is very much important, because we have studied what it is, and also we have understood what are the exceptions. Alva, Tollen's reagent ಮತ್ತೆ Fehling's reagent ಗೆ ಹೋದಾಗ ನಮಗೆ ಏನು ಗೊತ್ತಾಯಿತು? It is mainly it's a test for aldehydes, but along with aldehydes there are certain exceptions, that is with respect to your alpha hydroxyketones, formic acid, hemiacetal and terminal alkynes also gave a positive test for your Tollen's reagent. But when we consider with respect to the Fehlings and the Tollens, we have distinguished with taking an benzaldehyde. So whenever an aromatic aldehyde has to be oxidized and you have to know it, you have to use a Tollen's reagent, because Fehling's reagent is not having any capacity to oxidize our benzaldehyde. Coming with respect to the haloform reaction, of course we have dealt it in our previous video, but particularly in haloform I am choosing my iodoform reaction, because whatever the iodoform you are getting after the oxidation of your methyl ketones, it will be having an LOPPT. That can be used as a test for the identification of your methyl ketones, and there also we see an exception of a secondary alcohols of the type CH3CHOH. So these compounds are also on oxidizing, gives you the methyl ketone, which can easily undergo the haloform or the iodoform reaction when treated with the sodium hypoiodide. So soon after this, I have also given you a practical demonstration of this haloform. Have a look at it, you'll understood that why particularly we are using the iodoform for this haloform reaction for the identification of methyl ketones. Okay.